to acing your technical coding interview questions. So today we shall be looking at this question that says number of good pairs. So it says, given an array of integer norms, return the number of good pairs. A pair high j is called good if num high equals to num j and high is less than j. Let's see example. We have 1, 2, 3, 1, 1, 1, 3. So the number of good pairs. So there are 4 good pairs. Okay. So we have 0. That's the index. 1, 0 and 3. So 0 is 1, 0, 1, 2, 3. Is that correct? Oh, if it is equal. If it is equal. So 0, 1, 2, 3. So this is equals to this. And I is less than j. The index is less. So this is also equals to this. This is also equals to this. 3 and 4. Okay. 2, no. 3 and 3. That is 0, 1, 2. So 2 and 5. Okay, that makes sense. Here there are 6. This is 1. This is 2. This is 3. This is 4. This is 5, and this is 6. Here there's none. And the constraint is the length of the num is maximum of 100, minimum of 1, and the values minimum of 1, maximum of 1. How do we do this? How do we approach this one? First, we have this constraint that I should be less than j. So you might want to do a for loop, and that will be double for loop, and that will take quadratic time. So first of all, go through this, and the second for loop we check whether the second element is equal to the first. If it is, it will increment the counter by 1. Then continue like that until we get to the end. So double for loop definitely will give us an answer, and that will be quadratic. Can we do any better? I don't seem to see how we can do better. So let's code that first. If we can do better, we can try and do it again. So we are returning the number of good pairs. So number of good pairs we initiate that to 0. At the end, we are going to return it. So we need double for loop, and we need to go twice. So but we need the do we need the indices? Yes, we need the indices. So we can just use enumerate for I in enumerate. You always start from 0, nums. So that will give us the index and the number itself. Then for the second for loop, we can look for j in enumerate. We need that to start from 1. Okay, nums, and we can just take that as num2. We can use this one as num1. So what we check is if first I is less than j, so I should be less than j first. Then if I is less than j, we can now check if the two values are the same. nums1 is equal to nums2. Then we just increment our nums of good pairs. We just increment that by 1. And I think that's it. Okay. We can optimize it by combining this with this on this same line. So if I is less than j, we do all this. We check if it is equals and we increment it. If I is not less than j, then we don't bother. If I is less than j and they are not equal, we don't bother. Okay. So let's run through an example. Okay. Copy this. Paste. Why is it giving me something? Let's copy. Okay. Paste. Good. So I is 0. I think our j should always start from I plus 1. Plus 1. No. It can even start from I because we already said it should be less. So immediately it is not less, then so you can start from can start from anywhere. Immediately I is not less than j, and we don't have any problem with that. Well, let's try that. So our I initially will be 0, and our j will be equals to 0. Is I 0 less than 0? No. Then our I will become, our j will become 1. Sorry, our j will become 1. 0 less than 1? Yes. Is nums1 equals to this? No. J will become 2. Okay. 0 less than 2? Yes. So is it the same? 0, 1, 2? No. Becomes 3. 0, 1, 2, 3. It is less and it is equals, then our good pair will become 1. Okay. Then becomes 4. It is less and it is equal, it becomes 2. Then it becomes 5. It is less but it is not equal, then our I becomes 1. Our j comes back to 0. 1 is not less than 0. 1 is not less than 1. 1 is less than 2. 0, 1, they are not equal. Becomes 3. 1 is less than 3. 0, 1, because now our nums is now 2. Nums1 is now 2. because num1 is now 2, so we're checking it with the values as it goes on. Okay, 2, then we continue like that. Eventually it will now reach, then this one becomes 2, so the value will become 0, 1, 2, so this will become 3, and this will start from 0, but something will become interesting when it is 4. So 0, 1, 2, 3, 4, it is not equal, then it becomes 5, then it is equals, then increment this. Okay, so that should work. That should work. And if we look at this too, we're sure it should work. So let's run it because of our time. Oh, num1 and num2. Sorry about it. Num1, num2. Okay, so that works. So let's check another one. Now where our paste is not working. Let's see this. That works too. So let's check the last one. Okay, that works too. So good. So let's submit. Good. So that works. But we still have time. We still have 3 minutes, 2 minutes. Can we do better? Let's just think. Can we do better? Is there a way we can make sure it is not quadratic? Because the space complexity is constant, but the time complexity we have double for loop is quadratic. Can we do better? I can't think of a clever way where we can make this better, because we need a PS. We need a PS to be able to be sure of what are the good PS to be able to correct. So we need to take one and compare with all of them. So for now I don't see that. Anyway, thank you for listening, and see you in the next one.